Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first 4 parts of triangles where we have seen what are triangles and its properties, geometric centers of triangles, 30, 60, 90, 45, 45, 90 degree triangle and so on. In case if you haven't gone through those videos till now, the link has been given in the description box, please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see what are congruent and similar triangles and some important relations in a right angle triangle and basic proportionality theorem and midpoint theorem. So let us begin with today's video. Two triangles are said to be congruent triangles if they have same shape and size, whereas two triangles are said to be similar triangles if they have same shape. Here I have considered two triangles, triangle ABC and triangle PQR, and these two triangles have the same shape and size as well. So these two triangles can be termed as congruent triangles. Whereas in this case, the two triangles ABC and triangle PQR though have the same shape, but they don't have the same size. So in this case, these two triangles ABC and triangle PQR can be termed as similar triangles. Now, there are some conditions by which we can say any two triangles are congruent triangles or similar triangles. For congruency of triangles, the conditions are, the first is side-side-side congruency. That is, three sides of one triangle are respectively equal to the three sides of the second triangle. That is, for the triangle ABC, if the side AB is equal to the side PQ and the side BC is equal to the side QR and the side AC is equal to the side PR, then these two triangles can be termed as congruent triangles through SSS rule, that is the side-side-side congruency. In a similar way, if two sides and the included angle of one triangle are respectively equal to the two sides and the included angle of the second triangle, then the two triangles can also be termed as congruent triangles through SAS rule or side angle side congruency rule. That is, say for the triangle ABC and triangle PQR, if the side AB is equal to the side PQ, the side BC is equal to the side QR, and the included angle between them, that is angle B and angle Q, are also equal, then these two triangles can be termed as congruent triangles through SAS rule, that is side angle side congruency. In a similar way, if two angles and one side of a triangle are respectively equal to two angles and the corresponding side of the second triangle, then the two triangles can also be termed as congruent triangles through ASA rule. That is, say for the triangle ABC and triangle PQR, angle B is equal to angle Q and angle C is equal to angle R and the sides BC is equal to the side QR, then these two triangles can be termed as congruent triangles through ASA rule, that is angle side angle congruency. So two triangles are termed as congruent triangles through SSS rule, SAS rule and ASA rule. Also, the area of congruent triangles are also equal. So if triangle ABC and triangle PQR are congruent triangles, then the area of triangle ABC and the area of triangle PQR will also be equal. Now, two triangles would be similar if the three angles of one triangle are respectively equal to the three angles of the second triangle. That is, if angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, then these two triangles are said to be similar triangles. Also, if the ratios of the corresponding sides are equal, then also the triangles are said to be similar. By corresponding sides, we mean that if we take a side opposite to a particular angle in one triangle, we should consider the side opposite to the equal angle in the second triangle. So, if we are considering angle A is equal to angle P, then we need to consider the side BC and QR as this side are opposite to angle A and angle P respectively for these two triangles. In a similar way, angle B is equal to angle Q, so we need to consider the side AC and PR, and angle C is equal to angle R, so we'd be considering the side AB and PQ. And all these ratios are equal if the two triangles are similar. Also, if the two sides of one triangle are proportional to the two sides of the other triangle and the included angle are equal, then also the triangles are said to be similar. So here for triangle ABC, I have considered two sides to be AB and BC, and for triangle PQR, I have considered the two sides to be PQ and QR. And if AB upon PQ would be equal to BC upon QR, and the included angle between them, that is angle B, would be equal to angle Q, then these two triangles can be termed as similar triangles. In a similar way, if AB upon PQ would be equal to AC upon PR and angle A would be equal to angle P, then also these two triangles can be termed as similar triangles. So, if the three angles of one triangle are respectively equal to the three angles of the second triangle, or if the three sides of one triangle are proportional to the three sides of another triangle, or if the two sides of one triangle are proportional to the two sides of the other triangle and the included angles are equal, then the triangles are said to be similar triangles. Also, in case of two similar triangles, the ratio of the corresponding sides are equal to the ratio of the heights, which is equal to the ratio of the length of the medians, which is equal to the ratio of the circumradii or inradii, and so on. That is, say if we consider the length of the height drawn from the vertex A on the side BC to be say h1, and the length of the height drawn from the vertex P on the side QR to be h2, then the ratio of these corresponding sides will also be equal to h1 upon h2. Also, if the circumradius for this triangle ABC is say capital R1 and the inradius is say small r1, and for the triangle PQR, say the circumradius is capital R2 and the inradius is small r2, then this ratio will also be equal to capital R1 upon R2 or small r1 upon R2 and so on. So all these ratios will also be equal to the ratio of the corresponding sides. Also, in case of two similar triangles, the ratio of the area of the two triangles would be equal to the ratio of square of their corresponding sides. That is, if triangle ABC and triangle PQR are two similar triangles, then the ratio of the area of triangle ABC to area of triangle PQR would be equal to the ratio of square of corresponding sides, that is BC square upon QR square, or AB square upon PQ square, or AC square upon PR square. So, two triangles are said to be congruent triangles if they have same shape and size, and two triangles are said to be similar triangles if they have same shape. Two congruent triangles follow SSS rule, SAS rule, and ASA rule. And two triangles are said to be similar triangles if three angles of one triangle are respectively equal to the three angles of the second triangle, if the three sides of one triangle are proportional to the three sides of another triangle, and the two sides of one triangle are proportional to the two sides of the other triangle, and the included angle are equal. And in case of two similar triangles, the ratio of the corresponding sides are equal to the ratio of height, which is equal to the ratio of the length of medians, which is equal to the ratio of the circumradii or inradii, and so on. And the ratio of the area of two similar triangles are equal to the ratio of the square of their corresponding sides. Now, let us consider a right angle triangle ABC right angle at B. And let us drop a perpendicular from the right angle B on the hypotenuse AC at the point D. Now, if we consider the angle C to be theta, say, in that case, angle B is 90 degree. So angle A would be 90 minus theta. In a similar way, if we consider the triangle BDC, this angle is 90 degree, this angle is theta, so this angle would be 90 minus theta. And if we consider the triangle ABD, this angle is again 90, this angle is 90 minus theta, so this angle would be theta. Now, all the three angles of triangle ABC, triangle BDC, and triangle ABD are equal. So these three right angle triangles would be similar triangles. Now, since these three right angle triangles are similar triangles, their corresponding sides ratio would be same. Now, from these ratios, we'll be getting three very important relations, which are BD square equal to AD into DC, AB square equal to AD into AC, and BC square equal to AC into DC. Well, here I have not shown those ratios relationships and how we have derived to these relations. But if you guys are interested, you can write those ratios relationships and can derive these relations. But my suggestion would be to simply remember these relations, which would be sufficient. So if we have such kind of scenario in a right angle triangle, we can directly use these relations. Now let us see what is basic proportionality theorem and midpoint theorem. Suppose there is a triangle ABC such that P is a point on the side AB and Q is a point on the side AC, such that the line PQ is parallel to the side BC. Basic proportionality theorem states that the line parallel to one side of a triangle will divide the other two sides in the same ratio. That is, if PQ is parallel to BC, then AP upon PB would be equal to AQ upon QC. That is, if the point P divides the side AB in the ratio m:n, then the point Q will also divide the side AC in the ratio m:n. We can prove this simply by using the concept of similar triangles. If we consider the triangle APQ and triangle ABC, in that case, the line PQ would be parallel to BC. So this angle and this angle would be equal, as they would be corresponding angles. In a similar way, this angle and this angle will also be corresponding angle. So these two angles will also be equal. And in triangle APQ and triangle ABC, this angle A is common. So we can say that triangle APQ and triangle ABC are similar triangles. So if triangle APQ and triangle ABC would be similar triangles, in that case, their corresponding sides ratio would be equal. So we can write AP upon AB would be equal to AQ upon AC, which would be equal to PQ upon BC. So AP upon AB is equal to AQ upon AC. So we can say that AP upon PB will also be equal to AQ upon QC. So a line parallel to one side of a triangle will divide the other two sides in the same ratio. And this is known as basic proportionality theorem. The converse of this theorem is also true. That is, in a triangle, if there is a line segment joining 2 points such that this 2 points divides the 2 sides of the triangle in the same ratio, then this line would be parallel to the third side. So for this triangle, if P and Q divides the 2 sides AB and AC in the ratio m:1, then the line PQ would be parallel to the third side BC. We can also find the length of this PQ simply by using this ratio relation. We know AP is to PB or AQ is to QC is m:n. So AP upon AB or AQ upon AC would be m upon m plus n. So PQ upon BC can also be written as m upon m plus n. From this, PQ can be written as m upon m plus n times of BC. So if we know this ratio m:n, and if we also know the length of the third side BC, we can find the length of PQ. Now, if P and Q are the midpoints of the side AB and AC respectively, in that case, the ratio m:n would be 1:1. So m would be equal to n. In that case, PQ would be half of the length of BC. So a line segment joining the midpoints of 2 sides of a triangle would be parallel to the third side and would be half of its length. And this is known as midpoint theorem. So basic proportionality theorem states that a line parallel to one side of a triangle will divide the other 2 sides in the same ratio, and midpoint theorem states that a line segment joining the midpoints of the 2 sides of a triangle would be parallel to the third side and would be half of its length. So that's it for today's video, in which we have seen what are congruent triangles and similar triangles, some important relations in a right angle triangle, basic proportionality theorem and midpoint theorem. And in the next video, we are going to see some word problems based on the concepts and theorems that we have learned today. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing and keep growing. Thank you.